Alrighty, this is Calculus 2 for you wonderful people. Squeeze theorem. Find a limit. Find the limits involving trigonometric functions. Determine whether trig functions are continuous. Determine where a exponential or logarithm function is continuous. Alright, so we're actually not going to get through all of that today. I'm just going to get through part of it. So, squeeze theorem. So, this basically, suppose the function f, g, and h have properties that fall. Property that for all x in an open interval containing c, except possibly at c. So, we're basically trying to say, find the limit of x equal to the limit of h, which is the left side and the right side, at c. We're going to get the limit of g. So, squeezing, we're pulling the left side in, and then we're pulling the right side in, and then we're going to try and see what it's going to be in between there. Because usually we can't find the limit straight at g. So we're squeezing it in there to see what we get there. So if I could actually have everything included left and right into there, then I could find the limit of g there also. Alright, so find limits involving trigonometric functions. Suppose that a function f, g, and h have properties that for all x in an open interval containing c, except possibly at c. Now, limit of sine is at 0 is 0, right? So, sine wave, basically, right? Yes?
Yeah.
Okay, so now, since you guys already know this stuff, okay, this is a refresher on some of the stuff, and hopefully it will actually concrete what you already know. What is the derivative of sine? Cosine. What is cosine at 0? 1, right? Okay. So, there we go. Okay. So, it's really not much to this. Limit as x approaches 0, so of sine wave right here, left and right of the function. I'm looking here, right? Okay, both left and right hand go to 0. Okay, up here, cosine. Left side, right side of my function, both go to 1. Basic, right? Okay, so you have to know the unit circle. I haven't graded your quizzes, so I don't know if you know the unit circle yet. All right, so now, for this one right here, there's an identity in here. There is an identity. Okay, I'm going to use something that we already know because you guys did this class once already. We know that we could do what? What do you know already? So if I said find the limit at 0, you would do what? Do what?
Plug in 0 and see what you get.
Okay, plug in 0, we'll see what we get. In this case, what do we get? Okay, so 0 over 0, and if you could do that, then you come up with what?
You can do the L'Hopital's rule.
Very good, L'Hopital's rule, right? Okay, so if I'm going to do a L'Hopital's rule on the top, okay, so an identity which is not here, which is stuff that you guys have done before, so it's going to be this part. So it's sine of theta over theta. What's the derivative of sine? Cosine. So what is cosine at 0?
1.
What's the derivative of theta? 1. So sine theta over theta gives me what?
1.
1. That is an identity all the time. That will always be an identity. And you're going to see it a lot. Okay, now we're manipulating it. We're going to manipulate it. So in this case, we're going to change it up. We're going to manipulate the out of this. Now, this is saying that I have sine of 3 theta over theta. The reason why I was able to use that identity, I had the same thing. I had theta over theta, right? What's missing here on the bottom? That 3, right?
Yeah.
Can we put a 3 in there? So yes.
Yeah, why not?
We can put a 3 in there. Okay, we could put a 3 down here. Okay, then it would be 3 theta and 3 theta, right? So by putting it there, I'm going to put it there like this. Multiply top bottom by 3 over 3. Yes? So that's going to give me 3 sine of 3 theta over 3 theta. Now that these pieces here match, that goes with my identity again. So sine 3 theta over 3 theta gives me what?
1.
1. The identity was 1, right?
Yeah.
So that identity is 1. So this is going to be 1 times.
3.
So my answer is?
3.
That's it. Okay? Now, you guys already know this. You guys already know. Okay? We could get the indeterminate of this, right? So I'm going to go already into L'Hopital's rule for what we're doing. Because it's something you guys seen already, and it's a tool. Use it. Okay? You guys don't need to struggle over everything. That's why I kind of breezed over 1.1 and 1.2 already. And 1.3. Okay? But now, for this one right here. So I'm going to get into this a little bit more now. So we know that the derivative of the top would be what?
Cosine.
What rule is that?
Oh, chain. So
Chain rule. Thank you. It's chain rule. So I'm going to do this one again. Now this one is going to be chain rule. So the derivative of sine 3 theta is going to be
3 cosine 3 theta.
okay, cosine of
3 theta.
over. What's the derivative of the bottom?
1.
Right? Yes?
Yeah.
Okay. So now I did the L'Hopital. So that's the first derivative here. So now can I plug in 0?
Yeah.
Now I can plug in 0. Okay, what is 3 times 0?
0.
0. What is cosine at 0?
is 1, so then it's just
1 times 3, which again, this just gives me 3. ¿Está muy fácil? Sí. Are we good?
Yeah.
It's not that bad, right? Hopefully?
No.
Okay, good.
It is not bad enough.
Okay, so I'm going to get rid of that. All right, so now. This is kind of a hot mess over here, isn't it?
Just do the same thing.
Good. Could I do the same thing up here? I can't really manipulate it if it's on the inside, right? No, not really. I can't really do that. So, what should I do?
L'Hopital's rule, just.
We can go straight to L'Hopital's on this one, right?
Yeah.
Okay, it's a tool that you have. You already know this. Go to L'Hopital's. What's the... Now, right here, sine 0 over sine 0. Okay, what is sine at 0? 0. So I get 0 over 0, right? Okay, that's one thing. Remember when we did it the other day? Okay, 0 over 0, indeterminate, so I can go from there, right? So, I stated that it's 0 over 0, then I could actually do the L'Hopital's. So now, if we go with that, so the chain rule.
5 cosine.
So,
5 theta.
5 cosine of 5 theta over
2 cosine 2 theta. So it'd be 5 halves.
okay, and again,
1, 5 halves.
yeah. So 1 and 1.
So can you just use a number inside with theta to determine it? Kind of like a shortcut?
If it's approaching 0.
Yeah, it's coming at 0. So yes, you plug it in so you would state, so we get 0 over 0, the indeterminate, and then I could go with that. Yes? Okay. Basic trig limit. So it's kind of like that sine theta over theta. Here's another identity that we're going to use all the time. Okay, so cosine theta minus 1 over theta is going to give me 0. Okay? Now, Can I prove that? Say yes. Can we prove it?
Yes.
Yeah. Do you have a tool to prove that with?
Yeah, we do.
What's a tool?
Hold it down.
L'Hopital's. Now plug it in. Check it. So right here, cosine of 0 is.
It's 1.
So it would be 1 minus 1 over 0, which is 0 over 0.
Yeah, it's indeterminate.
Okay, so now indeterminate. So now I can go through and do the L'Hopital's on this, right?
Yeah.
So if I do L'Hopital's, the derivative of cosine is
Sine.
negative sine over 1. Okay. So now, can I plug in 0 here?
Sure.
Yeah, I can plug in 0 now. So now, sine at 0 is? So it's going to be 0 over 1, which is just 0. You are the negative 1. All right. It makes sense though, right? So this is a rule that you can always use. You don't have to do the math on it every time. It is something. So limit as theta approaches 0 of cosine theta minus 1 over theta is always going to be 0. Okay? All right, determine where trigonometric functions are continuous, showing f of x is equal to sine x is continuous at 0. The sine function y equals sine x is continuous on its domain, all real numbers, right? It's a wave.
Yeah, it's just
Okay, yeah, just continuous, right? The cosine function y equals cosine x continuous on its domain, all real numbers, right?
Yeah, it's still a wave.
Yeah, so it's a wave. Okay, here's a whole bunch of properties that go along with this. Tangent doesn't work at pi over 2. Because if you guys remember from trigonometry stuff, okay, tangent is what over what? Sine over cosine. Sine over cosine, right?
Yes.
And at pi over 2, what is the sine value at pi over 2? 1. What is the cosine at pi over 2? 0. So that's 1 over 0, so therefore that's going to be
Indeterminate.
undefined.
Or undefined.
Undefined, right?
Because it's not 0 over 0.
Okay, yeah. So, and that's odd multiples of this, right?
Yeah.
So what that means is, where else is it going to be undefined at? 3 pi halves, right? 3 pi halves.
The other side.
Yeah, 3 pi halves. So it's going to be, undefined at those places. Now, cosecant and secant, cotangent, no, those are all the same things. Now, we know cosecant. Cosecant is the reciprocal of what?
The 1 over.
Sine.
Yeah.
Woo, man. Okay, cosecant is the reciprocal of sine. Okay? It's the reciprocal of sine. So this one right here, that means that where sine would be 0, where the sine value would be 0, that's where it would be undefined. So starting at 0. Starting at 0. So at 0, the x value is 1, the y value is 0, right? And since cosecant is the reciprocal of that, it's 1 over 0. So 1 over 0 is going to be undefined. So I have my, right here, right? My cosecant. And similar for secant. But secant is every place that the x value would be 0.
So it would be the pi halves.
Yes, pi halves, right? Those are going to be undefined. Okay? So, inverse, all that good stuff. Okay? Do I need to go through all this? Say no.
No.
Please say no.
No.
Okay. It's on your notes if you need it. It is there. Okay? Theorem, continuity, exponential, and logarithmic functions. Okay? An exponential function is continuous on its domain, all real numbers. Right? Yeah?
Yes.
Okay,
X
yeah.
squared, you know.
Yeah, all that. Okay. A logarithmic function is continuous on its domain, all positive real numbers. Why has it got to be positive?
Because if you like look at it, it's like I don't know. I'm bad at explaining.
Because the log of a negative number doesn't exist.
Don't you get an error?
Yeah.
Okay, so if you try to graph, I don't know, just graph ln x.
Oh my god, so you missed them. Oh, that was me.
The domain is only positive numbers.
Okay. Try log x. Graph a log x.
Only positive
Hmm?
numbers. Only positive
Only
numbers.
positives.
I'm positive. Hey, look. That's why we actually did that. Based on this theorem, the following two limits can be added to the list of basic limits. So, limit as a of x, or a to the x, as x approaches c, basically just a to the c. For all real numbers, okay, c, a has to be greater than 0. A cannot equal 1. A cannot equal 1.
Because then just be 1.
Yeah, okay. And limit x approaches c, log a of x, okay, is equal to log a of c, right? For any real number, c is greater than 0, a has to be greater than 0, and a cannot equal 1. Whole bunch more rules. Okay, this is a lot of stuff that we did. Constant, right here, sine, plug in, there. Here's our rules that we already did, right here. Yeah, so, está muy fácil? Okay, all right. You guys got some problems? And we will work on it in class. Don't forget, like and subscribe.